Hello, everyone. Mr. Mechnick here with a podcast on analyzing data and drawing conclusions. Well, up to this point, we've been focusing on how we collect data in science. We spent some time looking at how we can organize our data in data tables, making sure we have proper columns and rows set up. And then we talked about how we can apply some statistics to make sense out of our data. What do all those numbers actually mean? Looking at mean, median, mode, standard deviation, and so on and so forth. But we also spent some time looking at making graphs, so it's another way to interpret what your data says. So what our data says is kind of important because it's part of the goal of doing science is try to understand and make understanding from some phenomena. So one of the things that we're going to focus on today is how do we go through and analyze our data to help us draw a conclusion. So when you are analyzing your data, it's very important you stick to the facts. What do you see? What do the numbers show? When you get to your conclusion, here's where we can use an explanation to try to explain why something happened using some of the supporting evidence from the data that you have collected. So for instance, one of the things that I would like all of you to be aware of is when we analyze line graphs. We know that a line graph is used to show how something changes over time, so we can easily discuss how the data does change over time or how it trends. So if we look at this graph where we're looking at weekly internet usage, and it shows the internet usage in hours on the y-axis and the days of the week on the x, it shows that there is some variation in the usage of students throughout the week. So one of the things we could do is discuss the range of the data. So this is a nice easy thing to look at, and we can say, well, it ranges from a high point on Saturday of 5 hours to a low point of only 1 hour of usage on Friday and on Tuesday. So obviously there's a difference of 4 hours between several days of the week. So when we indicate the range, we've also just taken into account our minimum value and our maximum value. So it's easy to identify those values when you are looking at a line graph. Find the peak, find the valley, identify what your minimum and maximum are. The other thing an analysis can do, it allows you to dig a little bit deeper than the obvious. So we look at the graph and we can see there are some peaks, there's a couple valleys, but what are some other things that we can do? One of the things we might be able to say, going above just some of the basic information here, we could state that, well, users tend to use the internet more often on the weekends than they do during the week. As you can see, 4 hours on Sunday, 5 hours on Saturday, so they're using the internet approximately 9 hours. We're not going to say why they're doing that, because we don't know why from this graph. What we do know is that they use the internet more often on the weekends than they do compared to the weekdays. We also could maybe look at, well, as a matter of fact, they use the internet more on Saturday than they do on Tuesday, Thursday, and Friday combined. So those 3 days alone don't equal what they use it for on Saturday. So those are just a couple ways that we can analyze a line graph. Now, we also could take that same data and we could plot it into a bar graph to show how much data or how much internet is being used during the different days of the week. So when we have a bar graph, now we know that we are comparing the data. We are comparing the usage over the days of the week. So an easy thing to look at here again is seeing these bars and how we can use this information to discuss some of the important statistics that we can pull from it. So again, discuss the ranges in your data, discuss your high points and your low points, which again stand out a little bit better on this bar graph as we look and compare some of the peaks and the valleys for a bar graph. And we could again state two other observations similarly as what we said on the line graph. So this is, again, an analysis has several different components, but it's very factual information. Students use the internet for 9 hours on the weekend, as opposed to 9.5 hours during the week. That's a fact, based upon this data. If we're looking at a pie graph, we know pie graphs are used to show percentages of a whole. So here's the perfect pie graph a pie graph of pie preferences. So again, I probably would fall in the 8% category here because there's nothing better than a nice pecan pie. But if you were to do this, you could discuss the percentages shown here and talk about discuss two of them. What was the difference between the greatest and the lowest? So 36% of people preferred apple pie, whereas only 3% preferred coconut cream pie. So again, there's some discussion that you could have stating some of the factual information from that graph. Now, when we do scatter plots in science, there's a lot of different components here that we want to take into account. We want to make sure that we plot our variables correctly. So in this case, we're plotting the class average of a test score and the number of missing assignments here on our x-axis. So we want to discuss the relationship between the variables. And based upon this data, we can see this slope right here, and it tells us something very important about that relationship. So first thing we would say, well, because as test scores, as the number of missing assignments increase, test scores tend to go down. So this is what we call an indirect relationship or an inverse relationship. So we would be able to identify that because it gives us a slope value of negative 4.95. So that means we have a downward slope, which again is inverse or indirect. And then the other thing we can look at is this correlation value. The correlation value is kind of important because it tells us how strong that relationship is. And because it's a negative 0.908, that's a very strong indirect relationship, which means most of the time as students miss homework assignments, their grade on a test would go up. As missing assignments increased, the class average will go down. So students tend to score poorer in a class as they have more missing assignments. That's an indirect relationship, and it shows a very, very strong indirect relationship because it's negative 0.908. So again, when you're talking scatter plots, discuss the relationship. How strong is it? Is it strong? Is it weak? Is it moderate? So we want to specify that. And I will give you a reference sheet that helps you with identifying if the correlation value is 0.3 or 0.5 or 0.8. What do those numbers actually mean? And again, that's something we can discuss during class. So when you are writing and analyzing graphs, pretend you're talking to someone younger. Explain to them what the data actually means. Don't try to justify, anything about the data. Just identify that there's a weak relationship. So in this example, we're looking at thumb circumference and the number of wins in a thumb wrestling tournament. So you have a weak relationship because the correlation value is negative 0.106. The last part of your analysis would definitely have to discuss some of those sources of error. So we've talked in length about the difference between systematic error and random error. So make sure that that gets put into your analysis paragraph. And again, don't just point the finger at someone or some person and say there's human error. Identify the actual problem as best you can. And the last part then, once you have your analysis finished, we want to come up and put a conclusion together. So our conclusion is going to really have three parts: a claim, evidence, and reasoning. So here, when we write this, we're going to use this general format, the CER format. So we're going to state a claim. What did you actually gather from your research? What claim can you make about this? So we could claim that students tend to use the internet more on weekends. Okay, evidence. We have lots of evidence to support that. We could support it by saying on Saturdays they use the internet on average 5 hours per day, and on Sundays they use the average 4 hours per day, which is both greater than any day of the week. And then here's where we would go through and have some reasoning. So the reasoning might explain why this is. So you might be able to say students are not in school, so they have the ability to use and have internet access more often during the weekends when they are at home. Maybe we look at, Tuesday nights as being a night where maybe there's a lot of activities at their school, so they don't have time to do homework and they don't have time to use the internet as much. So those are possible reasons why. If we're doing a true scientific experiment, we could look up and find the reason why that actually happens. Thank you for listening, and I'll see you in class tomorrow.